Okay, so let's do ones with unconventional units. Okay, a gas in a cylinder, when the piston is 10 centimeters from the bottom, right, it's at 12 psi. If it's quickly compressed to 5 centimeters, what's the new pressure? Now it should, these are absolute pressures. Okay, unless we say gauge pressure, we mean absolute, right? Okay, if it was a constant temperature compression, which it's not, okay, but if it were, we would expect the pressure to be 24 psi. That is, we cut the volume in half, we would double the pressure. But in this case, we're going to more than double the pressure because the temperature is also going to rise. That'll give us more pressure. Okay. Now, this is a piston, a cylinder, right, with a piston in it. Okay. And the piston is 10 centimeters from the bottom, right? And then we're going to look at it when it's 5 centimeters from the bottom, right? Okay, so the centimeters from the bottom is going to stand in as a proxy for the volume. It's directly proportional to the volume, right? The centimeters times the area of that is the volume in some units. So it would be, cubic centimeters if you did this in square centimeters. Okay, so we're just simply going to use the 5 and the 10 as volumes. Okay, we start off with 10 centimeters. We're going to go to 5 centimeters. That'll be our volume. So. And then we can use PSI because we're going to get pressure in PSI. Okay, so it's a bit like the combined gas law, where as long as the units are absolute, we can use them here without converting to pascals and cubic meters. Not so the ideal gas law, but for this, for the combined gas law, or for this equation as well, we can do that. So let's do that. Let's see, 12 PSI, right? And then this is really 10 centimeters times the area of that, right? This is really a volume times 5/3, right? And that equals some pressure. And then we're going to go 5 raised to the 5/3. All right. And now we can solve for this. Okay. So 12 times 10 raised to the parentheses 5 divided by 3. Okay, divided by 5. Raised to the parentheses 5 divided by 3. And I'm getting that this pressure is 38.097 psi. Now notice that, whatever these units are, okay, those cancel out because I go this divided by that, right? And then I end up with psi as my units, which is just fine. So notice, if in a constant temperature process, this would have doubled. Cutting the volume in half would have doubled the pressure. Notice that this much more than doubled it. Okay, should have been 24, but it's 38 because it's adiabatic. The temperature increased. Okay, because that's what adiabatic processes do. All right, adiabatic compressions do that. Adiabatic expansions, cool.